Okay. Srimitran, any questions for me or you're good? Okay, guys. How are you all? What are you doing in school, Vaibhav? Did you start with transformations?
No, we are doing the proofs.
The proof. So you're happy with whatever you're doing? Are you using what we do here to help at
Yeah,
school?
yeah.
Good to know. Now, other questions for Srishti and Pranav. What are you guys doing in school?
Um, we're doing like we're we're doing a Pythagorean theorem
You're doing Pythagorean theorem.
and then like distance formula and yeah.
You guys are too slow. Is it helping?
No, we learned this last year.
இல்லப்பா, இல்ல. No. What I'm asking is, what are you using whatever you're studying here at school?
Yeah, like for because distance formula since we did it it's like easier at school.
Okay. Okay. My question is, okay, is there anything, why I ask you this as soon as you come is there anything extra that they are doing that we have not covered? So I would like to help you. That's why I ask you every single week. Pranav, what are you doing?
We're doing like
If
distance
you can
between a
say, then
point.
it's easy. Huh?
We're doing a distance between a point and a line.
Oh, okay. Okay, that's good. Subi, you? Subi, are you following the same as Ashrita?
I don't know. I don't know because I'm in Frisco ISD.
I know. She's also in Frisco. Okay,
Oh,
what are you
okay.
doing?
We're learning like perpendicular bisector and like angle addition postulates, and we're just like learning. We haven't like started a new topic yet,
Okay,
but that's what we've been covering so far.
okay. So for this class, I remember in summer we discussed some of in-center, circumcenter, centroid, and orthocenter. I don't know how many of you remember, but I'll review that for sure. Okay. Mm, let's move on. Sahana, what are you doing, ma?
I'm doing the same as Sylvie, and we just had a test overall.
Oh, okay. One second, guys. Okay, I'll do. Okay, let's move on. My plan for today is, this is what is my plan. Okay. One is uh, a test on whatever we have covered till date. Okay. I'm not going to administer the test here. Okay. But I'm going to send you the test. You guys are going to deal with it. How much of integrity you have is on you. Okay. You're not taking the test for me. Attempt whatever you know, attempt whatever you don't know. If I start administering the test in class, for your accountability, you have to be accountable to the test for me. Okay, that's how I do. I rely on you, I believe in you. I know you guys are independent, nice people who will not cheat on these. There is no point in cheating, you see. There's no point in abusing. Okay, whatever you know, you're going to put in. If you don't know, please put that in and put wrong answers so that we can review those topics. Okay, that'll be a part of homework. It is a 25 question test till what we have covered. Okay, having said that, I really want to go to transformations. Okay, and discuss a few things about triangles, meaning what are centroids, what are orthocenter, all the stuff I want to discuss. Let's see how much of these we can take care. Maybe I will start here and then go to transformations. Let's see. I don't know how much of time we have. Or transformations, I'll start and go to that. Let's see. Now, okay. Oh, let's see. One second, guys. Okay. So I'll give you notes on this as well. Uh, I wanted to do composition first. Let's see. Okay, let's do the composition first. Now, till last year, you have all learned this. till last year in 7th grade, till 7th grade, we have learned transformations very nicely in 7th, okay? This is just a continuation of it, but I don't know how many of you really remember, okay? There were things like we did flip, turn, move, slide. What are these in geometrical terms? Who can tell me what is the related geometrical terms? Quick, come on.
Flip is reflection.
Reflection,
Turn and rotation.
turn is rotation,
Slide is translation.
slide is translation. Now, the thing is, these things you already learned, but we are just reviewing, okay? But there's one more, right? What is that?
Enlargement. Dilation.
Dilation, yes. Dilation can be enlargement or
Size.
huh?
Or reduction.
Reduction. Okay, now, one thing is, do you all know the difference between congruent and similar? Congruence and similar. How many of you know? How many of you do not know the difference? Can I ask Anish, what is the difference between congruence and similarity?
The difference between congruence and similarity
Hmm.
is can I just get my notes?
You can. Subi, you want to know, you want to tell us what is congruence, what is similar?
Congruence is like when it has the same size and same shape.
Mm-hmm.
And similar is like, is it like
Same
like
shape.
it's same shape but different size.
Good job. So here, this is similar shapes. Okay. Those are similar shapes. You know what is the notation for this? Please, this is important. You have all come to geometry. You should know the notation. This means they are similar. Okay. Same shape, same size. This means they are congruent. But how do I notate it? There is an equal to underneath. Any questions still here? Congruent and similar. Okay, you should not say, Auntie, what is this? The other day we discussed, I don't remember. Similar clearly does not have the equal to sign because they are of different sizes. Congruence has equal as well as the tilde. That sign is called tilde. Tilde, which is present on the top beside the one, left corner on the keyboard, left top corner beside the one. That is a tilde sign. The sign is called tilde. Okay, now let's go ahead. So we know, but why am I bringing these here? Congruence and similar need. Why? What is the relationship? Who can relate congruence and similarity with the transformations? Any thoughts? I welcome.
Maybe
What?
like dilations.
Dilations what? Dilations?
Because like when you have like
Sorry,
an
Ma'am.
original
I didn't hear you. What was that?
like when you have an like an original shape and you like want to find the image,
Let's call
instead
it
of, like,
pre-image and image. Always before a transformation, it's pre-image, right? Yeah.
like the original, right?
Yeah. What is this called? This is called an image.
So like when you have the pre-image, to make the image for like a dilation, you either like enlarge it or like shrink it.
Correct.
And that will like change the size, but it will be the same shape.
So the image and the pre-image here are what? Pre-image and image are similar or congruent?
Similar.
Similar. Okay, now you use pre-image, right? You applied dilation. That means what is the factor called? Meaning you're doubling or you're tripling the sides or you're
Scale
halving the
factor.
sides.
Scale factor.
What is that half double called?
Scale factor.
Scale factor.
Dilation uses a scale factor. Okay, when that scale, in case of enlargement, scale factor is
Positive.
greater than 1.
greater than 1. Positive lemma is greater than 1. Because if it is 0.5, it is reduction. Scale factor is less than 1 in reduction. Any questions still here?
No.
And I don't know how you guys have understood dilation, but I really want you to understand in terms of geometry, not memorize cheat sheets. If I'm given xy point, if I dilate it by a scale factor of k, then you know what happens? In the image, the pre-image xy gets transforms to kx ky. This is not what I want you to know. This is in a cheat sheet. You can Google and find out anywhere. But that's not what I want you to know. What happens in dilation? Let's draw and see. What happens in dilation? Okay, we have the origin. Okay, we have a triangle like this. We have a triangle like this. I want to double the size of it. How do you double the size of it? How do I double the size of it?
You have a scale factor of 2
Yeah, I'll have the scale factor of 2, but where to start? Let's say scale factor of 2. Yes,
at
correct.
the center of dilation.
See, you have a point around which you dilate. So you have a center of dilation. Always it has been the origin for you. It has always been the origin for you till date. But what does the center of dilation do? What does that point do with the figure for us to dilate?
Like when,
It's like
when you
Huh?
when you dilate the figure,
Sorry,
like,
sorry, I didn't hear you. What is that?
for example, like if A is the center of dilation and you dilate the figure, then
Oh,
A would
1 minute, Dhruv. You're going too far. I can't have A as a center of dilation right now. Center of dilation is the origin.
Miss Priya.
Uh,
Like if you have triangle ABC and the center of dilation is like the origin, it's like how many units you move from the origin to like point A, depending on the scale factor, you like double it or shrink it.
Good.
Like
Very nice. So I would like to have this as my center of dilation, meaning that is my pivot. That is my pivot. So from there, OA, let's say that is OA, I extend it. Now my scale factor is 2, right? So this distance I double and then mark a point here, A dash on that line. Now let me go to the next one. What do I do for the next one? Again, my pivot, I have to come to my pivot. I'm going to draw a line to C. Okay, now I will measure what is OC, double it and mark C dash on that line. Similarly, I will draw, again I'll come back to my pivot. The center of dilation is so important. It has always been the origin. That's why you multiplied. The coordinate multiplication came into picture. That is why. OB, I will measure OB and double it and keep the point B dash. Now I'll connect A dash, B dash and C dash. This is my image, okay? Dilated by factor of 2. Scale factor equal to 2. Any questions, guys?
Miss Priya.
Yeah, go ahead.
Is like measuring the only way you can like find the image using a scale factor, or can you use the points? Like
You
use the
can
small
use the
group?
point. See, let's say if this is x comma y, right? A dash, B dash will be kx, ky.
Oh, okay.
See, that's the easiest way. So if I say that first, right, you will all think you don't need to know this at all. But understanding what the center of dilation does is more important to me rather than memorizing xy becomes kx, ky. Make sense?
Yeah.
But why does it become kx, ky? Just because your center of dilation is 0, 0. If your center of dilation moves, everything will become avri. Okay, if your center of dilation moves, let's say this is my center of dilation, then the entire thing becomes topsy-turvy. Why? Because from A, you'll have to draw a line like this and then dilate it. To B, you have to draw a line like this and then dilate it. To C, you have to draw a line like this and then dilate it. Do you see? It entirely becomes different. So the way you work with a different center of dilation is different, and that's something we will learn in geometry. Center of dilation was always the origin without even understanding, oh, because of that only it became kx comma ky. It was so easy to do. Whereas if the center of dilation changes, we are for a task. We'll see that. Okay, I'm not bothered now. Okay, let's see. Okay, we will change the center of dilation. Okay, that is one. Now let's go back. What is this, guys? Okay, what type of pre-image and image this will produce? Pre-image is this. What type of image it's going to produce?
A congruent.
Congruent. Pre-image and image are going to be congruent. What is the scale factor here then? In case of these three transformation, what will be the scale factor? Here the scale factor is greater than 1 or the scale factor is less than 1. Scale factor here is what?
Equal to 1.
Equal to 1. Any questions? You retain the length of the shape, you retain the length of the sides exactly the same in these three transformations. Just because you retain the exact shape, size, right? So what is this? What are these three transformations called? There's a definite name for it just because the image and the pre-image are the same. There's one big name for it, whereas I can't call dilation as that. What is that name? Guys, think about it and tell me, guys. Dilation is different, but these three transformations are called something.
Rigid transformation.
Rigid motion transformation or rigid transformation. Make sense? Transformation. So what is dilation?
Non-rigid transformation.
Non-rigid. Make sense, guys? Rigid means the image and the pre-image are exactly the same. They are clones. Okay. And just because their sides are maintained, you see, this blue becomes this blue. The side lengths are never changed. The rose is the rose. Similarly, the orange is the orange, right? Since they are maintained, I would call these rigid transformations maintain or preserve isometry. What is isometry? Same measure. Whereas the non-rigid transformation do not preserve isometry. Srishti, are you following?
Yeah, I'm just trying to write it down.
Yeah. No, but if you understand when these definitions are discussed, see, you might not get it at school, but someday or the other, somebody will be discussing isometry. You should know what is iso means same, metry means measure. Same measure. Same measure is preserved, whereas same measure is not preserved. Any questions here? Okay. Can I go ahead? Can I go ahead?
Yeah.
Can I erase this completely? Okay. Now, I want to talk to you about orientation of vertices. Okay. Usually, if you're in 7th grade with me, now, I would have discussed this, but I don't know whether you remember. Orientation of vertices, let's see. What is this orientation of vertices? Okay. Let's make a translation. Okay. Let's make a translation. Translation means I'm sliding it. The figure becomes ABC. Okay. The same figure, I'm going to make a rotation of 90 degrees. Rotation clockwise 90 degree. Okay, let me do counterclockwise 90 degree. Okay. Counterclockwise 90 degree means maybe it becomes like this. So A shifts here, B shifts here, C shifts here. Now the last one is rotation. What is the one? Reflection. What happens? A, B, C. Okay. A reflection about the x-axis. On x-axis I'm going to do. Okay. X-axis is here. If I do that, what will happen? It will be a reflection on the x-axis, or no, reflection on the y-axis. I'll do.
No, the left side of the triangle would be B, the bottom would be A, and the right would be C.
Is this right?
Yeah.
Okay, good. Reflection on the x-axis I did. I wrote out the points. Now, either go clockwise or go anti-clockwise. Only do one, okay? Don't do both, okay? I will go for clockwise for now, okay? I will always start at A. I'll always start at A in pre-image and image. This is pre-image, right? What is the orientation? Orientation of vertices, A, C, B. I go clockwise, right? What happens here? In the image,
A,
I start from A, C, B. Did it preserve? Did it preserve the orientation translation?
Yeah.
Yeah, translation preserves orientation. Preserves orientation of vertices. How about this? You can be quick now. Rotation, did it preserve the vertices?
No,
No.
No.
Why do you think so?
it becomes CBA and another one is AC.
No, right, Dhruv, that's what I'm saying. You start from A always. Please start from A always. Don't get confused.
So,
From A, go clockwise.
so it does preserve.
It does preserve. Good job. It does preserve. Then
And the reflection doesn't, right?
ACB, let's try. ACB becomes what?
ABC.
ABC. See, always start from A. Go clockwise. See, ACB became ABC, so not preserved. So you have to remember these, okay? These are the fundamentals of transformations we would like you to understand rather than memorizing. Yes, I will give you the cheat sheet. You'll memorize x becomes y, x becomes minus x. That is easy to memorize. Okay, did you get this? Can I move on? So isometry is preserved in all three, but orientation of the vertices is not preserved in reflection. Can I move on?
Yeah.
Okay. Now, if it's okay. Let's see, dilated, let's see. For the other class, I did dilation. Let's see. Okay, how about this? Suppose I want you to understand this. Suppose I'm dilating a figure, okay? Now my center of dilation is not going to be the origin. Oh, before I go there, right, I forgot to tell you this. Okay, now for rotation, right, if you want to understand it geometrically, right, rotation, again, what is that you need? Meaning, do you need a point of rotation or a line of rotation? What do you need?
Center of dilation.
For rotation, dilation we discussed already. For
center.
rotation, what do you need? How do you rotate? Let's see. I want to rotate this clockwise 90 degree. How do you rotate this geometrically? Again, I have the origin as a center of rotation. It is my pivot point. What is that pivot point? I draw this line, OA. Now, if I want to rotate it clockwise 90 degrees, what will I do? Clockwise 90 degree means OA, I will draw a perpendicular line OA dash. That becomes A dash. Now, again from that pivot point, I draw B, OB, right? So now for OB, I will draw another perpendicular line to OB. Yama?
Nothing, sorry.
That will become B dash. Now OC, I will draw. The pivot point only determines where to where I have to draw. OC I will draw and then draw a 90 degree. See, the green lines are 90 degree, C dash. Now I will connect A dash, B dash, C dash. That is what you get when you rotate that figure 90 degree clockwise. This is how rotation is done with respect to the center of rotation. Make sense?
Yes.
Whereas, let me draw translation. I'm not going to explain. It's very easy, right? Now, coming to reflection, right? I have this. How will you reflect it on the x-axis? A, B, C, when you reflect it, this is easy. Reflection means this distance is one and the same. So you'll find that distance and then reflect it on the x-axis, right? So reflection needs what? A line or a point?
Oh,
A line.
A line. Line of reflection is always required. Make sense?
Yeah.
Okay. A line of reflection is always required for reflection. Point of rotation is required for rotation. Point of dilation is required for dilation. Okay. Now, okay. When it comes to rotation, right? Let's see. I want you to understand both. Okay. What is this? What is this? Have you heard of these terms? These all come from 7th grade only again and again. I'm just reviewing, not yet into geometry at all. Reflection symmetry, what does it do? Do you know? Let's say, okay, wait guys, I really want to show with diagrams.
Wait, reflection symmetry is like the shape with the line in the middle, right? And so it like reflects it on both sides.
Correct. The left side equal to the right side is reflectional symmetry. Make sense? So when do you have reflectional symmetry? The left equal to the right. How about this? Let's learn about the line of symmetry. How does that work? I will ask you some good questions as well there, right? So that way you learn better. See, come what may, whatever be the question, you should be able to tackle with these foundational understanding. How about this? A scalene triangle, does it have lines of symmetry?
No.
No. Isosceles triangle?
Yes.
Yeah.
How many?
One.
One.
Why can't this be a line of symmetry? Is this not a line of symmetry?
No, because the both sides are not equal.
Yup. A rectangle has how many lines of symmetry?
Like 4 or 2.
2, that is correct. 2, but why not 4? Can't this be a line of symmetry?
Yeah.
Yeah.
Huh?
Yeah.
It can't.
Yes.
Yes or no? Meaning is this a line of symmetry? Yes or no?
Yeah.
Yes.
Yes.
You know what? Let me show you. It's interesting, guys. When I draw like this, right, we tend to think that left is equal to right? But take this line as the mirror, okay? Now I'm going to show you how I'm making it as a mirror. This is what I'm going to reflect. When I reflect this on that side, right, meaning this line has to go here. But it is short, do you see?
Oh.
So the left side is not equal to the right side if you take that as a line of symmetry. Similarly, when I want to reflect this line, right, it will go only till here. But you have a bigger line. Do you see?
Yeah.
So do you think it's still a line of symmetry?
No.
No. So reflect it and see. Think this line is your mirror. Okay, when you put it on the other side, what will happen? Am I creating exactly the same figure as the left on the right? If your answer is no, it does not have reflectional symmetry. Meaning, rectangle has two lines of symmetry, but then the diagonal is not a line of symmetry for a rectangle.
Yeah.
Can I move on? Yeah.
So if you were to reflect like this part, then wouldn't it be like over here, like this?
Which one? I didn't get you. Can you explain to me once more?
If you were to like reflect like this like place over here, over this line, it'll go over here like this, right?
It won't, right? So this is a shorter line. This one goes only till here. Reflect this line. It will go till here. So you will get this figure when you reflect it. You see what I mean? But our rectangle requires you to have a figure like this. Do you get it?
Yeah.
Dhruv, did I clarify your question or not?
You did.
Yeah. So when you reflect it, you're not going to exactly get the other piece of the rectangle. So the diagonal is not a line of symmetry. Whereas a square, right? Square has all equal sides. Think about a diagonal. When you reflect it, it is exactly going to be the same. You got it? So square has more. Now, a regular hexagon has how many lines of symmetry? A regular hexagon has how many lines of symmetry? Quick, guys.
6.
Huh?
I think.
Huh?
Or 3.
3.
You think 3? Why? Wait, guys. I want you to follow some strategies. Equilateral triangle has how many lines of symmetry? Equilateral triangle has how many lines of symmetry? Equilateral triangle has how many lines of symmetry?
1, 3.
No, all the sides are equal, right?
3.
3. There's a pattern. Please start looking at the pattern.
So
Okay,
this
quadrilateral with 4 sides has 4 lines of symmetry.
has 6.
It has 6 lines of symmetry. There's a pattern if all the sides are equal. If it is a regular rectilinear figure, then it has how many ever sides in the polygon, that many lines of symmetry it has. Okay, now comes the hardest piece, hardest question. Okay, with this question we'll conclude. How many lines of symmetry does the parallelogram have?
2.
2, yeah.
What are they? Show me on the board. What are the lines of symmetry?
2.
Like, yeah.
Okay, Dhuru. Okay, wait. Dhuru has this. I'm going to draw that. Okay, Dhruv. Now, considering that as a line of symmetry, right? Let me ask you this question. This angle, okay, I'm going to reflect it up. Clearly, this is an acute angle, correct?
Yeah, I understand.
Do you think this is right?
Yeah, I understand.
Huh?
Yeah.
Dhruv, do you see my question?
It is equal. The
Are
angle.
they equal?
No.
This is an obtuse angle.
Yeah,
This is
and
an acute angle. Do you think this is a line of symmetry then?
No.
no. So it's
Dhruv, sorry, I didn't get you. What is it?
yeah. I'm saying it isn't. It's line of symmetry.
Isn't, yeah. I also think it isn't. Okay. And similarly, I'll ask you one another question. I mean, all of you said that there were two lines of symmetry, right? So let's see here. This parallelogram is a special thing. It is really a pain. How about this? When you reflect it, right? I'm going to reflect this alone, this piece alone, that side. I really would expect that to become this. This acute angle should have gotten copied here like this. But the original figure stays like this. So do you think it's a line of symmetry?
No.
No. So parallelogram doesn't have any lines of symmetry. Make sense?
Yes.
Okay.
Yes.
Now we understood lines of symmetry. We understood lines of symmetry. One another thing what I wanted you to understand. Yeah. For rotational symmetry, right? We didn't do this. You have to know for rotational symmetry, I really want you to understand what is the order. Vaibhav, are you following the class? You are?
Yeah.
Okay. So for rotational symmetry, let me see. Let me think about this figure. I don't know how to draw a figure with rotational symmetry. Okay, let's see this one. Ah. Please think all are the same beings. Okay. Now, this is the point around which I'm going to rotate. Does this figure have rotational symmetry? You just rotate the figure in its position itself. Does this have symmetry? Symmetry. How do you define rotational symmetry? Is, see, you have this figure. When you rotate it, okay, when you rotate it to any angle less than or equal to 360 degree, one full rotation, before you make one full rotation, how many times the figure becomes its clone? How many times the figure becomes its clone tells you the order of rotational symmetry. Does it make sense, guys? Okay, now I rotate this figure 90 degree clockwise. 90 degree clockwise I rotate. So what happens? Let me take the horns as A, B, C, D. If I rotate it 90 degree clockwise, what will happen? Horn A will come here, horn B will come here, C, D. Is this a clone of the original figure?
Yeah.
Yeah. So that is one. Now I rotated 180 degree clockwise.
That would
Horn
be
A will come here, B will come here, C will come here, D will come here. Still it is a clone of the same figure, right?
yeah.
So now how many times when I rotate, it will get back to the same shape? It's a clone of the original figure.
2.
Or why two?
Right now, 2 more times.
Yeah, because this will overlap with this once, then this has to overlap here, then this has to overlap here, and this was the original, correct? So there are 4 places where the horns overlap and still pose as the same figure, right? So order of this is 360 divided by 4. Meaning order of this is 360 by 90 will be equal to 4. Make sense? For every 90 degree, it's a clone. You see? So order of this, how many ever times you're able to rotate and make the clone of the same figure, it has that order of rotational symmetry associated with this figure. How about this? Let's say an equilateral triangle. What is the order of symmetry, order of rotational symmetry for this figure? What is the angle of rotational symmetry? What is the order of rotational symmetry? What is the angle of rotational symmetry?
60.
Yeah, no, it's
Please
yes.
understand you're rotating the entire triangle. Okay, you are making one full turn. Within that turn, how many times the figure will become itself?
3.
3. Order of rotational symmetry is 3 because if this vertex merges with this, original merging with B, merging with C. So order is 3. So what is the angle associated with the rotational symmetry here?
360 degrees, right?
No, right? Meaning
120.
huh?
120.
360 divided by 3. This is the angle of rotational symmetry. Do you see it?
Okay.
Okay. So those are the things I wanted you to understand about the order of rotational symmetry and the line of reflectional symmetry. Can I move on?
Yeah.
Yeah.
Now, see, now if I give you I'm going to give you the cheat sheet because I want to finish the curriculum too, right? So I'm forced to give you the sheet. Let's see. Okay, now, while this one we have already covered, guys, I'm not that very bothered about this. So this one cheat sheet I'm going to give, okay? So for you, see here, you all know this, right? Meaning, suppose there is a point xy. Suppose there is a point xy. I want to apply a translation of a comma b. That means x is added by a units, y is added by b units. That's just the slide, right? If you're going to go to the left, your a and b values will be negative. This we already learned. So any x comma y, if you apply a translation of a comma b, it will become x plus a, y plus b, that you know. Similarly, okay, let's talk about this. I have a point 1 comma 1. If I reflect it on the x-axis, what happens to that point? If I reflect it on the x-axis, what happens to that point? Sahana, you want to say? If I reflect the 1 comma 1 on that x-axis, what happens to the point? Guess, Amma.
Can anyone say it?
Yeah, okay, say it. Doesn't matter. You guys are very in high school. So yeah, go ahead.
1 comma negative 1.
1 comma negative 1. So what, see, when this is a very important concept, guys. When you reflect on the x-axis, because algebra 2, I'll be at the back of you if you don't know this. If you reflect 1 comma 1 on the x-axis, what value negates?
Y.
The y.
Y value. This is such an important concept, okay? Algebra 2 people, when they don't know, I get so frustrated. Now, let's see, when I reflect it on the y-axis, what happens? The same point.
The x value negates.
X value negates. See, whenever there is a negation on the x-axis, you can immediately say they have reflected on a vertical line. Whenever there is a negation on the y-axis, there is a reflection on the
X
sleeping line. You got it? So it is the opposite coordinate that is going to get negated. Make sense?
Yes.
That is why the cheat sheet is very good. See, reflection on the x-axis means y becomes a minus y. Reflection on the y-axis means x becomes minus x. It's very easy to memorize this. But how did they get that is something you need to understand. Okay, can I move on? The thing about the reflection, the y equal to x, right? This is our y equal to x line, right? The height becomes the the height becomes the base becomes the height. If you reflect anything here, right? Let's say you have this point itself we'll consider, okay? This is 1 comma 2. When I reflect it on this line, right? Automatically it becomes 2 comma 1. It switches. Do you see? That is how they get these formulas. Make sense?
Yeah.
Okay. Now you rotate 90-degree counterclockwise. You rotate 90-degree counterclockwise. Suppose this line, if you rotate 90-degree counterclockwise, what happens? You see, this becomes that line, right? So here, if you rotate it counterclockwise 90-degree, your x and y will switch. X and y will switch, and this x coordinate will be negated, meaning x became minus y, right? But you see, you are rotating it this side, okay? Your x coordinate will be, meaning your x, which is a y, will get negated. Similarly, 90-degree counterclockwise is the same as 270-degree clockwise. Any questions about it or no? Can I move on?
No.
Okay, now 270-degree counterclockwise. 270-degree counterclockwise. See what is happening. From here, you're going to rotate it here. 270-degree counterclockwise means what happens? Your x and y will get negated. X and y will get negated because it comes to this quadrant, right? X and y will get negated. That's it. I'm sorry. So from here, if you're rotating 270-degree counterclockwise, there will be a switch as well. There will be a switch as well. Only for 180-degree, they will be 180-degree, they will get negated. 180-degree is just negation, rotation, okay? Whereas for 90-degree counterclockwise, 270-degree counterclockwise. It's enough if you know this, okay? So x comma y will become what? In 270-degree counterclockwise, x comma y will become what? 90-degree counterclockwise means, as I said, right, they both definitely switch. But then your x coordinate will become negated. Here, it's just the opposite. 270-degree counterclockwise means it switches definitely, okay? But what negates this time is the x. Any questions? Okay, so you need to, meaning there's no other go but to memorize this, okay? Now let's say, yeah, the notations are all going to differ, guys. In geometry, it's not going to be that easy, okay? No, the bigger part in geometry is they will give you composition. Composition transformation means what? Composite figure means what? We have learned about composite figure. So what is composite transformation? Simple figures are this. Composite figures are this. Right? These are simple figures. This make up the composite figure. So you know transformation. Transformation is either translation, reflection, rotation. Anish, are you with me? Now, what is composite transformation? These are simple transformation. What is composite transformation? You can derive what are these. What is it? What is composite transformation? Guys, just think it out loud. It's fine to go wrong.
Is it
See,
like when the composite figure translates, reflects, or rotates?
Oh, you think like that? No, wait. Simple figure is this. Okay, simple figures are two separate figures. When it becomes a composite figure, the word composite is added means they are added together, right? Similarly, transformations are translation, reflection, rotation, dilation.
Yeah.
When I make a composite transformation, what do I do?
You add two of the.
I do two of them together. Translation, reflection, rotation or dilation, rotation, something I do. You got it? Combination of them.
You do one after the other, right?
Yes, order is so important, ma.
Okay.
Order is so important. Okay, order, they are not they are not back and forth. You can't go. Okay, meaning order is so important means you cannot change the order. If it is translated and reflected, it is translated and reflected. You cannot say reflection and translate. You have to find it out as translation reflection. Okay, meaning the order is quite important there. Okay, now the notations, right? I did not talk to you about composition notation. Let's see. Do I have it? You know, I do have it. Hold on. Okay. How about this? Yeah, when you rotate, okay, if let's say, two reflections on parallel lines, what happens, guys? If let's say I have a point, okay? I have a point. Now I reflect it on this line, okay? Then that point goes here. But again, I reflect it on that line. Then what happens? Two reflections means, can I say that that is equal to what? two reflections across parallel lines, if it is combined, what it would become? What transformation it is? Meaning two reflections, right? Meaning I take this point. I'll explain to you again. I take this point.
Rotation?
Wait a minute. I take this point. I reflect it on this line. The point came here. Then, so A became A dash. And then it became A double dash after another reflection. So these were parallel lines. Reflection on this line. Again, reflection on this line. Now, A became A double dash because of the transformation. If you combine it, what is that?
Translation.
Translation. You are just moving from A to A double dash. So if you can visualize and think, it's so easy. Okay, how about how about this? This is another catch. Let me erase this. Okay, suppose the same point. Okay, now I'm going to reflect it on the x-axis. First is a reflection. Okay, so A became A dash. Now again I reflect it on this line. What happens now?
It's rotation.
Exactly. If they're intersecting lines on which I reflect, right? So basically it rotated here. It rotated literally in this case, I would rotate it by
180.
yeah, 180. Got it? So basically two reflections on intersecting lines can be combined into one rotation. Yes. Two rotations around the same point, you can just add them together. So visualize it and do, then it's easy. Okay, let's see. How about okay, how about this, guys? Try this one. You can let me know. 2 comma minus 1. I don't know whether you remember the cheat sheet. If you want, I'll give you the cheat sheet. But try this one. Reflect it across y-axis and translate left 3. Reflect it across y-axis. Translate 3. Translate 3
What part?
left. Wait ma. Left. I did not talk to you about notation. Let's talk about notations as well. Now, go ahead with this.
-5, -1.
Oh, you got it?
-5, -1.
Okay, I don't know. Let's see. The first one is don't switch the order, guys. Reflect on y-axis. Now what happens? X negates, right? Okay. And then translate 3 left in a x value
-3.
minus
For the
5,
X value.
minus 1. So that is the A double dash. This is A. This is A dash after this. This is A double dash. Any questions?
No.
No.
So now if I give you a composition transformation, you are able to nicely find the points. But if I give you the points, I don't know whether you'll be able to find out what are the transformations. That I don't know. How about this? Okay, how about this? Let's see. I really want to. Okay, first I'll tell you the notation, guys. I forgot to tell the notations. First, let me tell the notations and then we'll discuss that. Notations are entirely different in geometry. We will not be using easy ones like what we have done before. Okay. So let me go back to the previous class. Notations, right? Transformation. Okay. This is a good one. See, this is what is going to be, this is what I want you to understand. Okay, guys. You all know this till date. Okay. But we will start referring to translation of point x comma y. Translation of point x comma y by a comma b. This is the notation I'll use. Suppose if I ask you to do this, okay, what is the answer? Who can tell me? This is the pre-image. I want a dash. What is a dash for this transformation?
-2, comma 8.
2 is applied -4, -2, comma
8.
8. Good job, guys. Okay, now the next one, reflection. See, reflection and rotation both start with R. So don't get confused, guys. Small r is always reflection. This says reflection on the x-axis. You are reflecting the point x comma y on the x-axis. You're reflecting the point x comma y on the line y equal to x. You're reflecting the point x comma y on the line x equal to c. Okay, you don't need to memorize this at all. It is just for your reference as an additional pointer. Okay, you need to memorize this. Ma, I'm going to supply the notes there, Ma, in the Google Classroom. Okay, you definitely don't need to memorize this. Okay, now coming to rotation, right? This is rotation. You see, what is this? Rotation 90 degree what? If it's not given, what? Rotation 90 degree, what happens? Is it counterclockwise or
Oh,
clockwise? Is it counterclockwise or clockwise?
X clockwise?
That's
Ma-
counterclockwise.
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 Yes, this is counterclockwise. Good job. Okay, x will become -x. See, this is rotation about 180 degree. It can be clockwise or counterclockwise. Both are one and the same. Here again, it is counterclockwise. Here, rotation 270 degree. It's not given. It's counterclockwise.
So like the angle of rotation is like positive, then it's counterclockwise. And if it's like negative 90 degrees, it's clockwise.
Correct. Good job. Very nice. So once you understand the basics, right, come what may, whatever questions they twist and turn, you'll be able to tackle things. Okay, this one, guys, it's dilation by scale factor of k. But you know what? I'm in a little hurry. I want you to understand this now. Okay, suppose I said the point of dilation. The point of the point of dilation was exactly the origin always, correct? So now I'm going to be changing. Let me see. I want one or two questions on that. Point of dilation, I'm going to change it. I don't have questions on that. Give me 1 minute. I want questions on that. Okay, how about this? Let me first explain to you what is that. Okay, now I'm going to dilate a point. I'm going to dilate a point. X comma y. Let me not give you examples. Let me dilate a point x comma y. Okay. I'm going to dilate the point x comma y by a scale factor of k, but my center of dilation is a comma b. It's not 0 anymore. This is my x comma y point. Okay. I'm going to dilate it around a comma b. Okay. So my origin is not my center of dilation. So remember this like this, guys. It's very easy to remember. Okay, what you're going to dilate. So basically, the distance between the center of dilation and your point is what you have to dilate. If you think about it, from the origin when you dilated, whether you reduced or enlarged, you dilated the distance from the origin. So the same logic applies. So if I have the point of dilation as a comma b, then I need to find out the distance of the x coordinate to a and y coordinate to b. So this is how I remember this. How will I dilate it? So I will find out x minus a. Okay, x minus a. This distance I'll find out, and then I'll multiply it with my scale factor. Whether it is increment or whether it is enlargement or reduction, I'll multiply it by k and add a, the point of dilation. Because from there I have to, right? So that's what I do. It's very easy if you remember it like that. Similarly for the y point, right? First you find out the distance y minus b, then you multiply it with your scale factor and add b. This becomes your a dash, the dilated point, the dilated xy. When you dilate it by a scale factor of k and the center of dilation changes to a comma b. any questions here, I'll give you one question, one problem. But how to remember this, I'm saying. First, find out the distance. X minus A is your x distance, y minus B is your y distance. Multiply it by a scale factor and then add your center of dilation. Make sense? Okay, let's try one problem on that we'll try. I will take this, I'll put it in the Google Classroom. Now, let's do only one problem on that, okay? Because if we keep, it's a lot to cover, but so I'll do 1 or 2 problems of one type. Okay. If they talk to you about similarity, if they talk to you about similarity transformations, right? Then what type of transformation will it entail? If they have similarity transformations, that means what transformation will it entail?
Dilation.
Dilation, good job. So it is always dilation because similar figures come up only with dilations. Okay. Now let's see. I want to give you one problem I said, right? Okay. About the origin I have. Let's see. Give me 1 minute, guys. I don't know where is that problem with. Ugh. Okay. Okay, around. Okay, this is good. How about this? This is one problem you can do. Now, first, this is one where M and P triangle. Okay. No, I just want you to do only one. It's a big problem. Okay, I don't want you to do this. So, see, when there are two dilations like this, it is called similarity transformation. Similarity, I am not asking you to do two. Okay, you can do one by one. Okay, that you can do it at home. But the basic fundamental concept is how to dilate it with a scale factor around a different center of dilation. So first, you find out x minus a, that distance, multiply it with k and then add it to a. Similarly, you go to the point B, that is your center of dilation, but then you have to find the distance y minus b, multiply it with k and add to b. This is what you need to do. Now, if I say this as m point, right, can you find out m dash? Srishti, am I clear? Yojit, are you following?
Yeah, I'm just like writing down like the notes.
Sure. So how do you dilate it? M dash, right? Pretty easy, guys. It's not a hard one, just plugging in. But only thing is you need to understand what you're doing here.
I got the X value. I'm doing the Y value.
Got it already? Okay, great. Okay, you don't need to, ma. Only one if you understand as well, it's a win for me. 1 point if you dilate it with a different center of dilation and with a scale factor. If you get it right, it's a win.
For x, it's referring to the coordinate of the m or like the center dilation coordinate.
See, I want point m dash, n dash, and p dash. Yojit, did I answer your question?
No, I mean like when it says x minus a, does x stand for -6 or 2?
X comma y is your point. K is your dilation factor. A and B is your center of dilation, right?
Okay.
Yeah, even one, if you get it correctly, I'm happy. At the end, you need the concept, not do more. Yeah, Mitransh and who else answered? Mitransh and I don't know. Hey, each one is giving one answer, guys. I'm a little torn. There is no common answer I'm seeing. Okay, is it difficult, guys? Ashruta, that does not seem correct. Ma Vaibhav, your left answer, the x coordinate is incorrect. Y coordinate is correct. Mitransh seemed correct for me. Ashruta, yours for some reason is not correct. Where are you messing up? I don't get it. I really don't get it.
Can I reattempt? I think I know where I went
Yeah,
wrong.
sure. Or if you want to explain as well, you can explain. We'll see. Vibha, again, the y coordinate, everybody is getting it wrongly. Why? Pranav, no. Pranav, can you explain what are you doing? Dhruv, correct. Vaibhav, correct. You corrected it, Vaibhav. Good job.
No, I got one correct.
Okay, I can do one, guys. For M dash, right? Let me see, Yojit. If you don't get it, explain, guys. We'll see. We'll think out loud. Amma, Yojit, your y coordinate is incorrect, Amma. Okay, I can show you one. Okay, it's the first time you're doing, I understand, right? So here, see, A is your center of dilation. Put that in here. Okay, and K is your factor, right? X is your point, -6. And then subtract A, center of dilation, 2. That becomes 2 plus half of -8 is -4. So that becomes -2. So X coordinate is -2, comma. For the Y coordinate, go with the center of dilation 2 plus half is your dilation factor. Y is your point minus what is B? B is your center of dilation, right? Center of dilation is 2. So this becomes 1. So will it not become a 3, guys? Did you get it?
That's what I got too.
What, ma?
I got 3 for the y coordinate.
Yeah. So yes, then that's correct. -2, 3 was the correct answer. And if you want the other answers, I can give it to you. N dash and P dash is what I asked you, right? I can give that to you. N dash is -1, 3, 2, 4. -1, 3, 2, 4. Got it, guys?
Yeah.
Okay, now what did I not cover? While I went over transformations, I remember discussing centroid, orthocenter, all that in summer, but I did not go over it today. Maybe we will continue transformation, composition transformation, similarity transformation along with that next week. Okay, properties of triangles.
Wait, Miss Priya, I got all the answers. Oh, wait, never mind. You already read
Correct?
it.
Huh? You gotta, yeah, I put it in there. Did you see the row?
I didn't see that. I got the answer.
Oh, good. Good. No, if you just know, it's enough. Okay. Dilation around a different point like that. But the homework will again scratch the basics. From the basics, I'll go. Okay. So see what you can do. You can, if you understand, miss out on the first few. If I say you miss out, don't miss out. Okay. Sit and do. Okay. And then, but make sure you do the composition transformations properly. Makes sense? There will be a chunk of homework. Any questions for me? Hey, Anish, I didn't get any answers properly from you. Any other questions for me? Can we stop here, guys?
Yeah.
And there'll also be a test of 25 questions. I don't know when you will take it. I will assign. Scores will be immediate. You do it at home. Okay, guys. But please do the test. I want to see how many of you do well. Okay. Any questions for me? Stay. Otherwise, we'll see you all next week.
Bye, Miss Priya.
Bye,
Bye.
guys.
Hi, Miss Priya.
Yeah.
Thank you.
Bye, Miss Priya.
See you all next week, guys.
Miss Priya, I just wanted to say, like, because for the homework, like because like the past few weeks we've had like so many things like in school. So I've been doing like the homework like half, like I've only done like half from like a lot of them. But it's like I understand it, but I'll try and like finish the entire thing this week. Like
Are you using what we learned here at school, Emma?
yeah. We did like some stuff over the summer, and I used that for because when we first started school, we did like bisectors and like postulates, and since we did that, it helped me.
Okay. See, with respect to the homework, right? Do alternate problems, ma. You don't need
Okay.
to do fully.
Okay.
Don't
Yeah.
tell everybody, meaning that you